Hello everybody, welcome to another stream. How we doing? So, let's get these head warming devices on. Probably not a good idea more than 5 minutes. Yeah, so last stream we fixed the upload buffer stuff and added... Oh yeah, we fixed the texture viewer because we broke it when we improved the upload and read back API and made it work between frame start and frame submit. So when we build the command buffer, and then we added different bottom level BVHs. So now we have more than one bottom level BVH that we can use to build a very simple scene. So currently this is our model 0 is our debug 1, which allows us to drag the leaves count. You know, if it's proper English, it'd be leaves count, but you know, it's programmer in English, it's leaves count. But anyway, so this just tests going from about 4 to 64 nodes in a tree, and it's just there's test a tree. So then we've got a different, so you can get like these complex models like this, and we can test to make sure that we can ray trace against it all fine. So the next models we have are this box one, which is made out of 6 ellipsoids on the faces, and then 1 ellipsoid in the middle, which is kind of a sphere. So it's just a box. The other one we got is this sort of tile. It's like a nice spongy floor. Yeah, we got this one. And then the last one is meant to represent a player, which is like, it looks kind of like a snowman, I guess. You know, head and a big body. Can't be bothered with anything else, because it's just too much effort, you know? So now we have 3 different models. I guess we have a 4th one as well, but whether we have 3 models that we can use to make a scene. So now we need to add support for a top level BVH. These are known as bottom level BVHs. So if we go back to this one, which we can show the example for. This is a BVH tree, right? So this purple outline is this 3 node here. And inside of it are these 4 children nodes, which are these 4 ellipsoids. Right, the 2 disks and these other ones. And this one outside here is 8. And obviously the root node is 0. So basically, this is the bottom level BVH. The leaf nodes are ellipsoids. So the ones at the bottom of the tree represent ellipsoids. This one has 7 ellipsoids. And they're all leaf nodes in the bounding volume hierarchy tree. So this is a bottom level BVH. Today we're going to be building the top level BVH, which allows us to have leaf nodes which point to bottom level BVHs. So that's where your instances come into play. The bottom, yes, the leaf node will point to other bounding volume hierarchies, rather than pointing to ellipsoids. So luckily, most of the code is identical, except for obviously the leaf node is different. So we've got to make an instance structure that we can point to from the leaf node, because right now the leaf node is an ellipsoid and it points to a material. So the ellipsoids in the leaf nodes will have an index to point to material, so we can do all the PBR shading stuff. So instead we need to make that pointer point to some instance data, which allows us to have a transform and point to another BVH as well. So let's get into the text editor. Let's go into here. Oh, only going to go into shared, isn't it? So we've got a thing called an ellipsoid. No, BVH node. Yeah, BVH node. So BVH node, it has word 3, 16 bits. So if it's a bottom level leaf, it has material index. So the whole node is an ellipsoid. It's got like half dims and center position and stuff like that packed in there. But depending on the node type, if it's a bottom level leaf, it points to material index. If it's just a parent, it points to a range of child nodes. So it just points to the first child node, and it can have up to 4 children. And the child count is stored in here as well. And then you got the... Wait, we changed how that works. I didn't change the comment. Anyway, we'll change it now. And the top level leaf, I say here points to a child BVH index. That's just wrong. We need to unfortunately, we can't point directly to another BVH, because we need to have a way of saying how do we translate it from local space into world space, or world to local, a world or local from world. We'll figure out which way we want to store it in the tree, whatever's more optimized. But I think we kind of need both anyway. So let me just quickly correct this. I didn't even change I just commented it out. Oh well. It was a silly idea. Yeah, we don't need more than 16 bits for this parent one. Yeah, we'll probably keep it 16. We'll make this unused. Let's go remember my keys now. Helix. Or I'll call that unused. But I hope everyone's having a good day today. Oh. Right, so the first thing we do is we get to build a data structure. It's my favorite part. I love building data structures. So if you're familiar with like the Vulkan ray tracing API, they got a thing called like wait a minute, let me find it. I did link to it in the Discord. This one. It's called a VK acceleration structure instance KHR. So they use the word acceleration structure, but it's probably safe to say that every implementation is a BVH. And then, like, okay, they could probably do something a little bit funky maybe, but it's probably always a BVH. So, instance KHR. So this one is, they've got a transform, and if you look at a transform, it's like 12 floats, right? It's a 3x4 matrix or a 4x3 matrix. It's one of those ones where it has an implicit bottom row of 0, 0, 0, 1. We have that in our arsenal, but yeah, so that automatically, if you're not packing it, that automatically takes up it says 12 floats, right? So that's 48 bytes, isn't it? Which is quite a lot. So what we're going to probably do is either pack a matrix, or we're going to split it up into position, scale, and a quaternion for the rotation, and pack those, right? Because I think we'll be able to pack it better, but a matrix will be faster to apply. So I got to think about that. Yeah, matrix would be faster to apply, but it will be take more memory, so maybe it's a good trade-off to pack it down into separate components. What else? So you need a transform. Then they have this sort of instance custom index that people can upload, which is 24 bits. There's a mask as well, which is used for a way to call instances that you don't want to ray trace against. They've got some offset into the shader binding table, which allows you to pick a different custom shader, right? They've got flags to do things like force opaque, which I guess is an optimization. Just tons of features, right? But the fun thing is, oh yeah, then there's the acceleration structure reference, which is a 64-bit int, which is basically a pointer. So you actually have to have pointer support turned on when you have ray tracing in Vulkan, or when you use the ray tracing API. We're not using the ray tracing API. We're doing it all in compute shaders manually. But this is just an example of a ton of. The reason why I'm showing this is because it has a ton of features that we won't need. I think all that we need is a transform and the pointer to the bottom level BVH. So let's see what we can come up with in terms of how much we can pack it. So we should size this up quickly. So that's 8 bytes, right? Here's another 8 bytes, right? So that's 4 bytes and 4 byte, right? Then this one is 12 bytes. Is that right? Has it really got like weird padding in that? Wait, 12 bytes plus a 4. You would have thought they would have made that 48. I don't know. Why would you make it a 12 float? Yeah, why would you make it a 12 float thing if you're not going to just waste it with padding anyway? Is there padding in this? Hey, chicken. How do you optimize your project in a way that you know what to work on when you feel like you've reached the dead end now? So you work on other bits of a project, then keep track of all parts. Do you have a planner of software management? No. Let's keep it all in my head at the moment. At the start, I was just building stuff because I fancied it. Like I was like, getting the abstraction layer, doing UI, getting a UI API in, getting a UI renderer in. I've been doing some rendering R&D, and just getting a feel for like if a thing is good or not, and if I should keep it or should I throw it away and try something else. But yeah, I think when you get to a point of getting fed up of something, that's always a good sign to move on. Maybe just put a pin in it or get it to a place where it's like, yeah, this is good, but I'm fed up with it for now. Or maybe you're like, to progress any further, you really need to answer other questions. Like right now, for crying out loud, this window. So as an example of what I want to do in the future, after this top level BVH thing is done. So, we built a bunch of bottom level BVHs, and I've manually hard coded these things. And I've got like PBR support now, custom materials, right? And I have to manually hard code everything. So what I would like to build next is some form of editor, because I've got a UI system, right? I've got this texture viewer that I've built, and I want to make sure that so I want to build this editor, and I want to make sure that the UI library or API that I've built is good to build that editor. And I'm not going to quickly build it. I'll take it because I want to try and not have to rewrite all the code again. So as I'm building it, I want to ask questions like, is this something that will be maintained, that won't be, would I want to rewrite this in the future, basically? Is it going to cause me issues if I write it this way? And if it's an inherent problem with the UI API, I'll fix it. I'll fix that aspect of it. Yeah, that's a bit of a side tangent. But so when I can build this editor, the editor is just going to be built so I can place ellipsoids down and build a model, right? Change some material properties. And then because I'll be able to make models a lot easier, then I can probably go back to doing some rendering and be like, right, these are things that I'm missing to be able to make things look good, right? Missing the ability to texture the ellipsoids, or now I can build a scene. I've noticed that I need to improve the lighting stuff, right? So it's more of just like building things until you reach a point where wait, what was the question? Yeah, so after you reach that dead end, it's like just going to place the next thing, which will help you answer the questions of how do I take the place where I got to dead end further, right? Yeah. And then, every time you go to a new area, like I want to build this editor, I want to make sure that I don't have to rewrite the whole damn thing again. So I'm going to, or have the painful thing of adding, because right now the program is single threaded. So I want to add multi-threading to my engine probably before I build the editor, because it'll be quite painful to add these things later on. So yeah, I'll probably diverge and build that thing first, fit it into the graphics system and the current thing we have now, and then get building the editor. So just be going around the engine and sort of just bringing other things up to a level of where the graphics is at now, right? So I guess if I could draw that out a little bit, we probably have like, if you just make it like a bar chart, the graphics is probably, say there's this box where it represents completeness. Graphics is probably like here-ish, where we've still another half to go or something like that, maybe more. We've probably got the operating system layer is probably also about half done. In terms of the engine layer, in terms of like structure of the overall project is probably down here where there's no multi-threading, but we've got some good structure, right? We're not putting ourselves into we're not quite a lot of technical debt. Things are separated nicely. We've got an engine folder with the core stuff in here, custom allocators in that, GPU, OS, UI. Graphics is in its own folder, all the game graphics. But yeah, in terms of like architecting multi-threading, which we're going to need, that's missing. Networking probably is missing as well. So this bar needs to come up a bit to join parity with these bars, you know what I mean? We've already kind of got some like gamepad support actually, so that's probably, and keyboard support. Well, that's part of the OS layer. Yes, OS, so just so you've got these sort of like, bring some of the things which are not as complete up a bit, and that helps you answer questions on how to bring these things up a bit more, right? I guess that answers your question. Very long-winded. Yeah, I have everything in my head. But, because here's the thing. As soon as you make to-do lists and notes, You have, and tests are the same thing. Unit tests are fine, the same thing. You have to maintain them, and then that's so much more, and there's so much more work you have to do. And then what else is there? Oh yeah, and then basically they get invalidated. So I think it's okay to write a plan up. I write plans up all the time. Sometimes I need to think stuff through. I write a plan. I've written like BVH, yeah, like a models plan on when I was doing these models. You know what? Some of this is still true. Other parts are really false now. But I wrote up the plan because I wanted to think about where I wanted to aim for. And I've got a game design document here on what I'm aiming for the game design. But it's written up purely to think about it and not to keep maintaining, right? So if I want to maintain it or do a new version, I'll look at the old one, take the bits out of the one, and start fresh again. And that'll be the new plan, if you will. But yeah, it's all in med. Is debugging between like a detective and a crime movie where you also are the murderer? No. How are you a murderer? Yeah, you're a detective in a crime movie, but that kind of twist. What about the overall design of an application or game? I'm not sure. It's a bit of an ambiguous question. Maybe it's a bit too big. Well, I want to design that data structure. So BVH instance. Oh, it's going to be good. So we'll put it under a. You know what? Copy paste, my friend. So we're trying to do something like a BVH instance. We've got to be careful because there's going to be like a BVH instance on the CPU as well. So we could probably call this. You could call it instance data, but that's what strut is. A strut is data, so it's kind of a terrible name. You could call it node instance, or no, you can't call it node instance. That's a terrible name. So on the CPU side, we have instances of something. Oh no, but that would be like a model. And then a BVH instance will be, yeah, is the implementation detail of how things are rendered. So in here, we want to store a 20. Is it 24-bit? Is it a node ref? Oh, well, yeah, okay. We'll just use a BVH ref. And maybe we'll make it 24 bits, we'll figure out. Yeah, I want to try and make it 8 bytes. Because then you can fit 8 in a cached line, and that should be alright. So, oh no. Maybe you can't do 8. Maybe it's got to be 16 bytes. Yeah, because our BVH node is 16 bytes. It's 4 U32s. Because I don't think we're going to be able to pack position. We might be able to pack a position. So these be uploaded every frame, so you don't have to worry about interpolating this transform, this world from local transform or whatever way around it is, because it's getting regenerated every frame from a higher precision, or from local matrix or something. Yeah, so you don't have to worry about. So I think we can use. So the thing is we've packed things down. Oh, where's the damn? Oh, here it is. So we've already kind of used. Yeah, I think we've got to do a very similar thing. We could use a very similar packing. So it could be like a scaling thing, and then like a. Yeah, so why don't we take all, we'll just take all of this. Yeah, we could probably reuse a lot. Yeah, why don't we just take it all? Seems alright, isn't it? Investigating misdeeds. I guess so. But murder seems a bit crazy. Murder seems like it's unrecoverable. It's a bit like playing a doctor where I don't know. That's probably another very terrible analogy. I get, yeah, maybe it's a bit like no. No, terrible analogy. Right, so that'd be pretty decent, I reckon. BVH instance. We can just make it the same as a. So say if we made it 16 bytes, how much more packed are we than the Vulkan one? Because I never really answered that question. So that's 12 times 4, so that's 48. Right. And then that's right, and it's 12 floats. Right, let's use a calculator so my brain is not getting fried. And I always doubt myself heavily when I ain't got the calculator by my side. Yeah, 48 plus another 4 plus another 4. So it's 56 bytes. Oh yeah, then use 8 bytes here for the pointer. That gets you to 64. Right, so they get into one cache line per instance. Whereas ours is 16 bytes, so we get 4 in a cache line. Yeah, I think that's cool. I was hoping to be like half the size at least, but if we can get it down a quarter, that's an interesting one. We'll see how it goes long term. But yeah, so I think we'll base ours off of the node. I like that idea. Let's quickly. Let's quickly figure this out. All right. Unfortunately, let's find the word node. Man, I love making custom data structures. It's one of my favorite things. So we're going to take in some. There's no instance type, right? Load of baloney. So there'll be some center position. Are we going to say? So that's not really center position anymore. It's kind of like what are your translation? So we want it to be like probably world from local. Because you can always invert the thing maybe. Or should we just do a matrix? If we did a matrix and then you packed. So if everything was in. So you're always going to want to. Yeah, so I think in CPU side, you're probably going to have some, like you say, position in the world. It's going to have this sort of coordinate in the world, this sort of scale, and this quaternion, right? But I think in the BVH, yeah, so the BVH node, it's the previous one BVH node had it wants everything in assigned normalized space. So we can always like multiply that by the sort of dimensions of the bounds to get it back into a world space thing anyway. I guess. Yeah, so I guess we keep the same things. If we keep, so there'll be separate these world from locals. Yeah. Okay. So if you want to, the problem is if you want to move it back, I guess you would just do some subtracts, some divisions. You maybe inverse the, right. And then, yeah, inverse the rotation. Just do it backwards. Yeah, I think that's okay. I'll figure out how we want to change it. But I think this still works out. So let's search for node. Here, okay, I did already change it everywhere else. Hey, Crazy Blue, how you doing? Welcome, welcome. Let's move that there. So what is different to this instance data? We've got the transform in here now, right, coming in. What else do we need? Oh, yeah, we need that reference, isn't it? So it's going to be the, we want to have the BVH ref. Right, and I think that's all we need. So we've just got to pack this data into 16 bytes. Should be easy. Oh crap. Yeah, so if we keep them the same as the BVH node was. We're going to mark this one as unused. And also it's a bit silly, why isn't this padded out a bit like that properly, you know what I mean? Let's fix these ones quick. Okay, so BVH instance gone unused. There's no children count here, so that's 4 bits unused. Oh, let's just delete that line. And then 16 bits is a bit low, so if we move that up to wait, it's BVH ref. Yeah, 20 bits is probably enough. That's like 1 meg. Yeah. So if we made it 20 bits of we could probably get away with, yeah, we get away with that. I think so. So if we capped BVH ref to 20 bits, that would then mean you're 1 million. You can reference 1 million nodes, but a ref, right? Here's the thing about it. It's a base node index. So what does this mean? It's always aligned to 4. So if we really wanted to go more in the future, yeah, it's always aligned to 4. So here's what we're going to do. We're going to make it 22 bits. So it should be, yeah, it should be 4 million it should support, right? So basically you just shift right by 2, and you AND it with 0x. So you got to 20s, that's 4, 8, 4, 8, 12, 16, 20. Right, and then we'll keep the sets 1, 2, 3, 4, 5, 6, 7, 8. Hang on a minute. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So yeah, we can say like we can put a nice little comment here and just go base node index is always aligned to 4, right? Since since siblings are allocated all together. So in groups of 4, right? Neat. So this means when you extract out the base node index, it is simply doing a shift left by 2. And voila. So this means now our BVH ref actually fits into 20 bits. Hey Raymarch, how you doing? Welcome, welcome. How did the stream go the other day? So we'll say like we'll say like, oh yeah, we only use Oh, no worries. No worries. I'm always looking for people to raid. I'm starting to just end my streams sometimes because I just, don't find anybody. On bites. Bits. By the way. But yeah, have you noticed anything different about my setup? I use Helix now. I have abandoned Vim / NeoVim, and I'm learning a new thing. Right, so now we should be able to pack that as 20 bits. And we've got 2 extra bits to use for other things in the future if need be, even though I've got to change all the packing stuff. So what's really nice is we can just keep, like we know this all works. We can keep all of this. And then word 3. Alright, just gotta be a bit careful. But yeah, how's Shame going, very much? What you been up to lately in Shame, in the land of Shame? So I want to do like a BVH reference, shift left by, so 20 bits, so it's 8. Wait, no, 12. It's already been handed, what should have been at least. Alright, let's have a bit of a think. BVHRF comes in 12. Yeah, it comes after that one. Neat. So now we just got to change all of these initialization thingamajigs. So we don't have to worry about these special initializers because we only got one type of BVH instance compared to our node, right? We don't have an instance type. We have a center position, a half dims, and a rotation. These could be thought as translation, scale, and rotation. We don't have a children count. We don't have a material index. We don't have a BVH, child BVH, but we have a BVH ref. That's what we end up calling it. It says shift right 12. Neat. And then gets you back BVH ref. Nice. So, I didn't change this to instance, you see. Rightio. So, this is amazing. Although, what is that unused? Ooh. Let's do that. Right, we just need to change one more thing, and in the BVH node, now if it's a top level BVH, we're instead going to go, we point to an instance, a BVH instance index into the instances array. I think I call it an instances index. I think I like pluralizing it there. But yeah, so instead now, in top level, I don't know if we use these in the end, to be honest. All right. So what else has changed? Oh yeah, then the getter changes, obviously. And that's it. Right, so that's our new lovely data structure designed. So now we have a BVH instance. We should be able to make an array of these, populate them with something, and then build a top level BVH, which has these instances, references to these instances. Right, let's get something up while I read the chat. Oh, the crap has gone in here. What did I break? What did I just change? I just changed comments, man. Yeah, just some stuff over the weekend, yesterday, just to see if I can improve the packing of the ellipsoids. Oh, right, we just got a really weird. What? Are we inside the things? Right, something broke. Valid node type 3. I don't know what we changed and what we broke. That is bananas. Oh. Oh. Right, I've broken something. We'll look into that. Knee deep in Vulkan type system pain. Good old console. Did you keep in bindings? No. I heavily changed it because I use the Comac keyboard layout, and because it's a terminal application, they use key codes instead of scan codes. So I've had to basically redesign it anyway, and I've been finding my own sort of key layout. It's quite nice. I've still got a way to go on making it 100% though, but most of the basics are there. I want to sort of get my muscle memory around this current configuration, and then I'll tweak the odd little key to improve it, and just have to, we get. I'm working on getting a single trait working for all buffer types. Right. Yep. While not losing the functionality like compressed vertex attributes. Right. Basically bridging the gap between Rust RepRC standard 130 or 40 vertex layouts without too much type system friction. Oh my days. Interesting. Yeah, it sounds like a right big pain. I wonder how you'd do that. See, I just stick with standard 430, which is basically C style. Anyway. But yeah, you want to support more things, isn't it? What did I change? Seriously. it was just working, so it's none of this. Because I tried to improve my packing the other stream. Oh, sorry, off stream. But it ain't anything to do with that. It's to do with oh yeah, I changed the way the BVH ref works. There it is. So maybe maybe we did need more than 20 bits. Hang on a minute. Yeah, this is this thing that broke it. Base node. Right, first of all, that needs to be in brackets. Like, that's super silly of me to do that. To not put this thing in brackets. Oh wait, I can do something new. I can go like that. Oh wait, I could do that. M surround in brackets. Anyway, I don't know if that's the fix. Right, so why oh why? I'm gonna make a BVH ref. Where do I do this? Can I search for like references? Yeah, so block start ought to, oh, right. Block start is not packing into, okay, I just returned it as an int. It's pretty unsafe. I should really wrap it in a type, to be honest. Right. Anyway, wait, what? Oof. I should do. But I don't know. Oh, wait, what am I doing? Right, that's the fix. So when I retrieve, take my BVH ID, turn into BVH ref for the GPU. There we go, we're back in business. All right. So now we have an instance data structure which has a transform and a BVH reference in there, which takes up 16 bytes of memory. So we need to point our leaf nodes to that. So if you take a look at, leaf nodes are the top level BVH. If you take a look at a Vulkan, the way I think it works is you get the API is that you give an array of BVH. The API, I believe, is you have a buffer filled with this VK acceleration structure instance, which is the equivalent of our BVH instance, but it's like 4 times bigger than ours. You take an array of that and you feed that to the BVH builder, or the acceleration structure builder as they call it. Right. So we're basically going to rebuild a top level BVH every frame. I don't know if we're going to have multiple, but we'll have multiple if we have multiple views, right? So maybe it is kind of a nice API to do it that way. So I think let's have a think about it though. Because the problem is that the instance has in like unorm space or whatever, right? So when you have your so you're ray tracing from view space, you're going to world space. Or you might be ray tracing like a signed norm version of world space, probably. Hmm. I'll take these off. It's getting a bit warm now. Very warm day. I feel things like U8 norm vertex attributes should really just be types within the shading language, but they probably didn't do it because it'd be easier to standardize a new enum. Yeah, I turned those things into proper types in the shader. Cool. Interesting. Hmm. Yeah, for mine, when I did textures, I made it so that the type you put in for the texture type was the literal size of the type. So there's no automatic translation between yeah, for storage textures. So sample textures are different. It does the automatic translation, but storage textures are mine. The type that you see in there is the actual type in the texture, and you have to do the packing manually because I didn't want to fight with all that. Putting special attributes above my textures to say, oh, but the underlying, but the underlying format is this one. So instead, the type matches the format directly. Yeah, silly. It's a bit of a trade-off because it has actually made some issues. Like I can't write directly to the swap chain anymore. I have to write to a temporary image because it doesn't have the correct things to help set it up. But I'm quite happy with that trade-off, to be honest. But yeah, it's all very silly stuff. Yeah, exactly. That's what I basically settled on, is removing that auto magic stuff, as you phrase it. Because yeah, it was. I feel like it is kind of nice in a way that it automatically unpacks and packs textures, and so you can keep the same shader code. But then sometimes this is the reason why. So when it comes to render targets, this is the reason why pipelines kind of exist, so they can optimize the instructions in the shader code. But then I think when it comes to textures specifically, you don't know that. Like they literally do not know the type because it's a runtime, right? Especially in bindless, or even it's not bindless. When you bind a descriptor set, even, and you grab the texture from it, you still don't know the format until you execute the code. So I wouldn't. I think they have a bit of hardware to do that. They must have a bit of hardware that automatically does it, because in software it just sounds horrible to switch between all those different formats and unpack a texture. BGRA LGB, yeah, right, yeah, the automatic swizzling, yeah, right, okay, hmm, right, I see. Yeah, because then you can like generate stuff from that, isn't it? Basically, and yeah, it's more fixed. Oh yeah. Because sometimes you get a vector. You always get vector fallbacks in in the other languages. And they automatically put an implicit, they automatically fill in the last column, you know, with a 1. It's an alpha of 1, which is kind of useful. But yeah, it's magic. Right, so when it comes to these sort of like BVH instances and nodes, I want to pack. I'm packing world space. Yeah, sort of these world space things into a -1 to 1 space. So, see, I wonder if I should do the scaling automatically in these functions. It's a bit like, so if I ray trace the scene, do I want to be in, so I'm ray tracing a bunch of objects. I could do it in this sort of signed normal space, right, from -1 to 1. It'll still be in world space, but it's just I've mapped it into -1 to 1 range. So I have a min and max world space, if you will. And so I can ray trace it in that space. But so when I hit an instance and then I want to go into local space, my world, yeah, my world from local, which is this stuff, so it goes the other way, should probably take -1 to 1. It should be dealing with that sort of, that side of things, I reckon. Right. Yeah, I think we can do that. Yeah. So how do you scale? Yeah. Rotate. Yeah. Because otherwise I have to have a world bounds and I'll be doing divisions in here. If we keep everything in that space, and then we can record our hits, and then we can always just scale it up after the fact. If need be, I think. Yeah, we'll keep it down in sign norm space and just see how it goes. All right. Because it makes it really easy to pack and unpack. Okay, I think that's good. So when we build this top level BVH, we want to make these instances, and so on the CPU side, there will be some sort of world space dims that it, or it's not even world space dims, it might be, maybe we put it all in view space actually. Yeah, it's going to have to be in view space relative from the camera because it's all packed data. Right, that's okay. It's, yeah. Right, that's fine. Right, that's good. Yeah. Yeah. Rightio. So I think let's make the new API then, and we'll fill it in. So GPU, not GPU, GFX. So game graphics, .h. Wait, it's internal. Okay. So this is our BVH node allocator we used to allocate BVHs from. Here's our BVH API, build bottom level from CPU data, right? Here we go. So, yeah. Oh, we've not done the shrink 2 stuff, isn't it? We should probably get that working. So BL will change to TL, top level. So this is going to hold all those instances. So you got a range of instances, and then could you ever want to do this from the GPU? I don't think I will, right? Let's have a think about it. So I think we're going to have a bunch of models that have a bunch of BVHs. Those will compute an array of BVH instances all on the CPU. We'll then upload those to the GPU. It will build a top level, and then it will be used to ray trace against. But you only need to do that if you need to do every frame. But we might be able to get away with it if only rebuilding it every few frames. Maybe. But that's an optimization detail. So I don't think we need that GPU one because, well, we could have all the models on the GPU and then just run a couple of compute shaders, but that just takes probably more work. So in future we can just add that if need be. So we just need this new function here. So we're going to copy this and then we're going to go full ham. Damn it. I'm vimming. Stop vimming. Yank. Right. Cool. So basically we do all this, right? We generate some linear sequence and we generate some more codes, and like then we finally have this sort of like ellipsoid thing here, right? So oh, that's just a BVH. So it's a bounding yeah, so this model here that you're seeing here, right, made of random ellipsoids. Each leaf node is the ellipsoid, and then obviously these other ellipsoids are the parent ellipsoids that wrap around the child ellipsoids. And we ray trace against this acceleration structure, basically. It's all built on GPU. So we're currently looking at the code which builds it or dispatches the things. Yeah, I think we've got these sort of like, these should be leaves, and maybe maybe yeah, So it's rather than axis line bounding boxes, it's just rotated ellipsoids. Um, yeah, going up the whole way, basically. Yeah, so it should be it's something different. I've got to try and solve the problem of building really nice fitting ellipsoids that surround ellipsoids. Someone sent me some maths stuff to do with like building a covariance matrix and then using I think it's called eigenvector or eigen. I don't know how you pronounce it. I always pronounce these things wrong. Eigenvector decomposition and getting the eigenvectors and the eigenvalues, and you get this orientated ellipsoid. And I've been trying to do that. I tried to do that yesterday whilst I had some time off, and yeah, I couldn't do it. I tried. I tried to do the maths, and my brain was dying. But I tell you what, I got the eigenvectors, but I didn't get the eigenvalues properly. The eigenvalues are actually off, but the vectors are correct. So I could. Yeah, it is. It's a lot of heavy maths, but I could probably get the I could probably calculate the eigenvalues by doing a just simply doing a vector projection thing. Um, but I want to get it done properly because I want it to be fast. So, uh, it's just yeah. Anyway, I think I might solve it properly in the future when it actually becomes a problem, or try and get someone else to help me to do it because yeah, maths is not my forte. Or maybe I should get good by then. Yeah, they're arbitrarily rotated. Yeah, so it's quite the thing is if you look into covariance matrices and eigen I don't know if I pronounce it eigen vector decomposition is honestly it's like let me enable the code I was doing yesterday. Um honestly, you just take a group of points, and with that group of points, you compute your covariance matrix. Then from that group of points, you produce an ellipsoid that wraps around. It's like it is pretty good. Oh, for crying out loud! Unused. And it's so damn warm today. But yeah, so essentially, let's go back to something basic. I think I'm getting the vectors right. I actually didn't check the other ones. But yeah, so these are the points like that are the bounding boxes around the ellipsoids. So this is actually way too small, this one here, but the the normalized vectors are correct. It's just the sizing of them is horribly wrong. But I only really tested it on this one to be fair. But all these points represent the bounding boxes around. Yeah. So you just can make a covariance matrix from that, and then yeah, but my math skills are terrible. Yeah, I'm not sure if that vector's alright, to be honest. I don't know, I can't see the rest of the ellipsoids. Maybe it's fine. Yeah, I could probably cheese it. But I don't want to cheese it. In a situation like this, how do you select which ellipsoid to choose? More like blue versus orange. Do you choose those in the closest coverage or something? So your four ellipsoids, looks like a person with goggles. Boom. What do you mean the ellipsoid to choose? Well, when I build the bounding ellipsoid, I just take a min-max volume at the moment. So the one I do at the moment is very, very crap. So as to draw your example and hopefully not produce a very ugly image. But anyway, basically I just produce a min-max bounding box for them all. And then I just take that. Oh, for crying out loud. I then just produce a min-max, and then I multiply the min-max by the square root of 3, so it's guaranteed to fit the min, and then voila. Yeah, it's not best right now, but yeah. Oh, the black ones are the objects, and these are the bounding ones. Right. Yeah, the safe one for now. But yeah, I need. Yeah, so to get the tighter ones working, honestly, that the eigenvector decomposition thing seems like the way to go. You just make a group of points, turn that to covariance matrix, and then get the vectors from that. But yeah, it's very complicated maths, and I've got the vectors right, I think, but the values are wrong. But yeah, I'll come back and do it at some other point. I'm not really too fussed right now. Right, so let's take this pack quad tree structure and see what we can do about it. I'm probably just gonna dump my code. When I was talking about the covariance thing. Yeah, so basically when we pack the quad tree, we've already built the quad tree. We're just going up the... Sorry, you've already built the build version of the quad tree. It's unpacked, it's horrible. Not good for traversing. So we pack it down, get rid of the root node, and then we've got 4 root nodes at most. So we do that from the bottom up, and we're building the ellipsoid thing using our algorithm we just went over in the diagram, right? Go over all the children, get them in max, and then multiply by the square root of 3. So yeah, it's quite horrible, but it works. So this is the other version where it's that covariance matrix thing, but has not panned out yet. So basically, we've got a thing where we say, hey, if we are a leaf node, right, get the bottom level BVH ellipsoid. Now, what we could do is just have a constant and just go, is this a top level build? Is this a bottom level build? And then with that information, we can just go, oh, okay. If we're a top level BVH build, then our ellipsoid should be the ellipsoid that is defined by maybe we'll square root of 3 it, but it should be the instance. Comes from the instance data instead, right? That's interesting. But yeah, so I don't think we should. So we could put if statements in here, or we could copy paste the shader. I think we should put an if statement in there because it's basically, this is where people would use permutations and stuff like that. But I'm all for if statements right now. So when it comes to these things, though, yes, I think we'll so we'll say this is a Boolean, but Booleans are not ABI. Booleans are not ABI compatible between CPU and GPU because a Boolean in SPIR-V can be any size, and I just made mine a U32. Yeah. Random side tangent. Values of this type can be either true or false. There's no physical size or bit pattern defined for these values. So it's not 1 byte, it's not 2 bytes, it's not 4 bytes. There's no physical size to... There's no definition for it. It could be 1, 2, 3, or 4 bytes. It could be 8 bytes. We don't know. So my Boolean type is fixed to a 32-bit int because by default we don't have byte sizes on GPUs. So my Booleans are not... Unfortunately, they don't work across CPU and GPU. They're not ABI compatible. Yeah, Boolean. It's hard, isn't it? The elliptical test is faster than the box test. I don't know. Yeah, I think the code is similar. It's like it's a bit of a slower sphere test. Yeah. But so it's probably better than the box. But don't quote me on that. I'm not. I think it is. Just trying to analyze the two implementations I've seen. Have you implemented networking stuff like HTTP? Right. I've not done HTTP, but I've done... Right. So when I did networking, did my own sort of protocol stuff on top of the operating system, there's a really good library. So yeah, whenever you're doing something in C and want to see if there's a library for it, check single file libs by obviously Sean Barrett. They're not his ones, they're ones that he recommends. Now, there's a section for networking. And the one that I used, well, I actually took it and changed it because I think the error handling was a bit off. But it's called ZNet, ZED-net, not ZNet like this. People might call this ZNet if you're American, but yeah, ZNet. But this ZNet. This one is a higher level thing. This one is a lower level thing. And it just literally abstracts over TCP and UDP APIs on Windows and Linux, and probably Mac as well. It's 400 lines of code, does the job, and you can just take it and change it and, you know, obviously give them credit and stuff. But I highly recommend starting there. I've never built any HTTP stuff though on top of that. I'm not the person to talk about that, but that's where I started at least. If you're looking at doing it from scratch. But if not, just ignore what I just said. And I want to make my own HTTP one, but I don't know how to get started. Like the basics of socket apps. Yeah, so that uses WinSock, I believe, right? The name WinSock just makes me laugh. Yeah. Implements WinSock. So you'll be able to use this as an idea of how to use the API. Christmas ideas, WinSock. Oh boy, a WinSock for Christmas. Right. Yeah, they probably are all 4 bytes, but someone was telling me that GPUs a few years ago, not a few years ago, probably 10 years ago, they had special registers for Booleans. So they had like a flags register where all the Booleans went. Hey Glorious sir, how you doing? How you doing, sir? Hey Kept Pain. New Epic chips are gonna have 512 L3 cache. Oh, megabytes L3 cache. Neat. If I remember correctly. Amazing. Could fit my whole application in there right now, maybe. That's the dream, right? Fit all the code in cache. And then fit as many assets in there as well. And voila. You can definitely fit all your code in there. Unless you're using C++ and got all those debug symbols in there. So on a new rewrite, a read-only buffer. Oh my days, what did I do there? But yeah, how's it going, Glorious Sower? How's your projects going? What have you been up to? BVH instance. So yeah, you have the instances and you have your instance index. Yeah. Right. This is good. So when it comes to for the instance, you have 20 or yeah, like a million. Yeah, we don't have to worry about start index, do we? Yeah, we do. And then like an is top level. So I think we've got enough. Wait, we've got 64. So that's enough for 16. Yeah, 16 of these, isn't it? So that's all right. Plenty of room. So I think if we just get back to the packing quad tree shader thingy. So if we're a leaf node, we just put a lovely old if statement in a shader, like it's not even a problem at all. Problem for current Henry, but future Henry is gonna be like, and then right. So, ooh, indices. We need an indices buffer. So I could call this leaf indices, and that would just be no, because so you get your index for the leaf, and you store that in the in the node. We can always just add another one, but it's the same. It points to the same thing. Yeah, I think we'll call this build leaf indices instead. Yep. So that would be pretty ideal. We get to share this thingy. Go to start, next. Right, so you get your leaf indice. this will get your build ellipsoid here. We want to get the, oh shoot, BVH instance, I think. And we want to probably extract out BC BVH instances BC BVH instances star index plus leaf index. So when it comes to, I guess we'll just copy all this in it. Top level leaf. Right, world from local. So the ellipsoid, it probably has, if we extract this all out, that would be BVH instance center position. It's not picking it up. Yeah, I don't really like buy new hardware. I like buying the old hardware and saving some money. You know, I like getting a good trade-off between price and performance. So then when I bought this new PC at the beginning of the year, or beginning of last year, it was already like 2 or 3 year old hardware, and I quite liked that. It was just good enough for me, you know. But when it becomes about, yeah, whenever this PC gets old, I'll buy 2 year old hardware again, save me some good money. But is the AVX 512 stuff fixed now? Would that be good? Because I've heard mixed things about it. I heard people say, oh, it was fixed ages ago, and then some people go, no, it wasn't. It's still broken today. OpenGL 6, sorry, 4.6 spec, uniform buffer storage, members of billion type int, uint flows. Respectively extract a buffer object by reading a single uint or a double value. Yeah, but that's in a uniform buffer. Uniform buffer is standard 140, and everything is 16 byte aligned and 4 bytes in size, right? Yeah. But buffers are different. Yeah, I think. Doing fine. Was thinking about talking about game design lately. Haven't done much programming since asset packing. We'll do some font rendering exploration next and how things going. I understand for sure. I'm happy with AMD 3700. I just want to try AVX 512. Yep. Right, game design, nice. Yeah. Have you got have you written like a game design document before, or is this for this current project you're doing, or you have you got an idea for a game you want to do? But yeah, to be fair, like the asset pack and stuff sounds like a load of fun, but I'm sure it's like any old thing. When you're first doing it, it's like, oh, this is gonna be amazing. I'm gonna do this, I'm gonna do that, and then when you're going through it, you're just like, um, just want it to be over and to be done with it and move on to the next thing. Yes, the circle of life in programming. So I think we can just. What's it called? Rotation? I think so. Oh yeah, that's such a neat feature. This is like the best feature of Helix. I just press the F key and just jump to anywhere I want in 2 more key presses. Bam. Legit. I need to use it more. And the ref index, do we have a ref? The ref would be the instance of the leaf, which is a pointer to the instance in the array. Look at that. So that right there should be us being able to share the exact same shaders as the bottom level BVH, just with a few little changes to the final shader. So let's get in there and do some things. So I think we want to copy. So right, so we want to allocate. Right, so ellipsoids buffer ID, start index, ellipsoids count. So I think we want to make another function prototype. We'll oh, internal API. I can make some internal API. I try not to forward my API and never allow them to be uploaded. Makes things much simpler, yep. Otherwise there will be a vendor specific vector type that's not size, which makes things annoying. Well, there already is one. Well, you said vendor specific. Oh no, sorry, you didn't. One specific vector type, there is. The vector boolean type. Yeah, I removed that from my shading language. I decided to make all of the boolean them to return signed 32 vectors. Yes. That's what I decided to do in the end. It was the silly thing I had to decide to do. Because having a Boolean vector type just made it weird. I did something like game design documents for tabletop games that I made with my friend, although made a very hard word because we took the existing game and although made is a very hard word, we took the existing game and did so called total conversion with significant changes, modding basically, right? Current idea is super young, so we're just exploring some ideas and verbally before getting it down on paper. Nice. Awesome, so you got someone else you're working on it with. That's cool. That's very cool. You'll be able to actually achieve a lot more, hopefully. Yeah, I always find it really difficult working with somebody else. Because, like, for me, if I work with someone else, it's going to have to be completely different domains. Or I would be paying someone else to do something. Um, so damn warm. Right, build from GPU data, and we'll slap a thing on their internal. Someone doesn't use it. Like me, I don't use it. Right, Leafs buffer. Leafs start index. Rather than leaves because English. Because not English, that's why. Leaves count. And then what? Boolean is top level. Neat, so we're gonna make this one. It's basically gonna steal. Shoot, what I do there. I keep doing that. So that. Right. Then I jump. So I can just go F, AF, GT, and then paste. Right. It's a bit out of order, isn't it? Yeah, it's in the wrong order. Right. So we're going to move all of this lovely code from within inside this function. Reuse all of this. So I just mi and then d it. Neat. mi that. Replace it. So I've moved all the contents from one function to another one. So let's patch this internal one quickly, and then we'll right, so where we've got ellipsoids, we change that out for neat. So leaves count. Next one with problems is this ellipsoids buffer. It should work for the word ellipsoid. Yeah, this should be renamed too. There's a rename thing we can do. Is it R for replace? Oh, there's a rename in it. Rename to leaf indices. That'd be nice. So I want to also change this locally. So right. So for every one of these. Not really every one of them, but I'll do it anyway. Okay. Right, so we generate a sequence of indices from 0 to number of leaves. Generate them all in codes. So this is like ellipsoid more in codes. Crap. We've got to change this one as well. So we might have to change that shader name. Generate. Yeah, so then unique, sort them all in codes, memset the new buffer to 0, uniqueify the molten codes into the new buffer, build the binary tree, build the quad tree, and then build the packed tree. So let's just get these in correctly. So this one's actually leaf indices. This one is actually going to go back to ellipsoid. Oh, then this one is actually ellipsoid start index. Whoops. Right. So we actually want to populate. Oh, for crying out loud. Keep doing that. So this yank paste. There's another one called instances start index. Well, didn't I change that in the shader code, isn't it? Leave start index. Yeah, let's get rid of that. Right, leave start index. We're gonna do the other one where it's like bc.is top level. And then we've got to get the other node. So this would be instances. So we've got to somehow fill in those instances as well. Okay, I think that's all of them. Let's just double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. Right, so we've sorted out this shader now. We just have to sort out this shader here, which generates the Morton codes. And then we need to actually call this build BVH internal function from the top level and bottom level functions. And then we have to populate, we actually have to make a buffer called instances as well, and bump allocate from that. Yeah, it's hard to talk about artistic stuff with someone but once you've achieved some understanding, it's super helpful to hear another opinion. We call it sanity checking. Yep. Yeah. Awesome. Yeah, definitely. Sometimes you don't know if an idea is good enough, and you need someone to bounce ideas off with who's not really necessarily someone who's gonna just want to talk about their idea and say everyone else's ideas are terrible, or not just wanting to yes man your idea and be like, oh yeah, your idea is great, go and do that, and it's actually terrible. Yeah. Hey SV7CC, I'm sorry, but is this a game, or are you a hacker or something? It will be a game someday. I got a game design document, but yeah, we're building out this sort of engine groundwork. There's a game design, so you have one. It's 18.4 kilobytes of memory. Bytes of memory. Yeah, it's got words in there. It's got a design. I still got to flesh the design out a bit more, but it's what I'm building towards at the moment. But when I have a sort of when I get to a certain place in development where I want to really iterate on the design of the game, I will obviously revisit that and then start implementing some of it. But right now we're implementing all the sort of just getting the visuals there and getting the groundwork of the engine together to build this game. But I'm still liking the idea. I'm still thinking it's the one I want to go with. And I need to make a plan, if it is the one I'll go with, how I actually want to succeed at building it. Hey Swank Funk, how you doing? Any plans for summer, mate? Yeah, we've just been I've actually got 3 days off. Was it Thursday today, isn't it? So I just spent the day with the family today. We went for a walk and did some shopping and preparing for the little one's birthday. He's going to be 1 in 2 days. So Saturday we're throwing a little party for him, a little children's party. Got the cake ordered. We could pick up the cake tomorrow. Going swimming with the nephews and the niece. It's going to be a lot of fun. Yeah, just hang around with family, really, basically. Other than that, staying indoors doing programming. Because, yeah, I'm moaning that it's too hot. This is the way. But yeah, how about you, Swank Funk? Are you up to much? So let's go back to shader code. So there's like a build ellipsoid. I don't even know anymore. Oh my, just made multi cursors. Gen ellipsoid Morton codes. Right. One, we're renaming that. But let's get in here and right, so it just makes Morton codes. That's all it does. So maybe we should have a different shader actually. Yeah, we're not renaming it. Past Henry was not equipped with the knowledge of present Henry. So present Henry is discovered. An if statement in here is probably going to be dumb. So generate instance more codes. So we'll just make a specialized shader. And we'll let the shader compiler, not my one, the driver one, be like, oh yeah, we don't want to pull all 16 bytes back. We want to use a pointer. Because you can't express pointers in shading languages. (2024) and I ain't got me no pointers. Oh, ain't got me no pointers. BVH instance center position sign norm instance, voila. Wait, I think I could do something magical. Oh, wrong one. That one. I gotta get all these key presses down. Then I'll be a ninja. Again. I'm re-earning my ranks, you know? Right, so we got... This is a new shader, right? It pulls an instance out, unpacks. Actually, we might need to pull some bits out because thinking about it, the center position is probably spread over a few different 4-byte words. I think it's in the top word and the other word. The second word. The word 0 and word 2. Oh well. We can probably not a big issue. Center position. Wait, what am I doing? Why put an instance in there? What Wally? Center pos. Then convert from sign norm to unorm. Throw into Morton 3D 30-bit, gives you back a 32-bit int, chuck it in the destination buffer, and voila. So let's make this guy. Ain't too hard. Copy paste it. look for ellipsoid, you know, multi-cursor, instance. Get rid of multi-cursors with the mouse because I don't know the shortcut key. BVH instance. Oh. And voila. So there's a new shader. We're going to go into where the dispatch is. If is top level, right? Else am I one of them? Yank it. Am I that? Overwrite it. Look for ellipsoid again. Instance. So it fills in destination buffer, the Morton code, ununiquified. Source buffer is the leafs buffer, and there we go. So I think that's this lovely internal function which can do top level and bottom level BVH builds. Cool. Now we've got to go ahead and figure out how we're going to implement these guys. Right, so this is where it came from. This one's the easiest. Let's just have to recall. Return BVH build from GPU data internal. BVH ID, ellipsoids buffer ID, ellipsoids start index, ellipsoids count is top level false because it's bottom level BVH. Now, the top level one from CPU data, so this one's from GPU data, so it already has the buffer, but this one you did it from CPU pointers. So one is top level, so you want to replace that to true. But you know, there's a bottom level from CPU data, and what this one does is it gets the BVH and it bump allocates some ellipsoids in the ellipsoids buffer, and then it will upload them, and then done. So we basically want to do the same sort of thing, but we want to do it with instances. Yeah, I really don't think we're going to have multiple top levels, but we might do. So, let's go ahead and rework this a bit. So, in the BVH build strut, which goes in the graphics strut, it's just a global. It's amazing. We want to have a instances buffer next index. Now we've got an ellipsoids buffer here. We also want to have a GPU resource ID of instances buffer ID. So this one we still need to initialize, obviously, because we just made it. But we now get to replace all of the word ellipsoid. Let's just go around like that. And we've got to make sure that we actually zero it at the start of the frame, because it bump allocates it, right? Oh shoot. Cool. So we bump allocate our instances on there, build leaves, sure. Upload all of our instances. using the upload buffer API, copying them to the staging buffer, and then it will get copied later on the GPU. Now, instances buffer ID, this guy. Oh, for crying out loud. Start index, good point. And then number of instances. And there we go. So that should be the top level BVH API sorted out. So we should be able to build top levels now. But we can't really test it yet, because we need to solve the ray tracing code to handle these top levels. Yeah, because right now we just ray trace a single BVH, which is the bottom level, and we need to have a way to, when we hit a leaf node and it is a top level leaf node, we need to swap out to another BVH, traverse all of that, and then come back out to the top level and, you know, do some more ray tracing or traversal there. So it's like a one item stack there. So I guess let's begin on that next. Hey there, Kostrumhan. Hey there, which program language are you using for your day job? So this is not my day job here, but I'm using C. But in my day job at work, we use C++. It's kind of C style C, but not. Yeah. Unfortunately, we still use constructors, destructors, inheritance. I've seen. I've actually used inheritance as well. Lambdas. Lots of templates, but not ridiculous amounts. Only in collections, typically. But I've seen them around in other places. You know, there's quite a lot of different collections and types that wrap stuff with templates. What else? But yeah, it's kind of C-like. I'm quite happy with it, to be honest, because it's not like ridiculous C++. Because when I look at C++ code on the internet, it's horrible. Like the amount of the way people just, you know, make stuff into ridiculous templates. They'll operator overload the most ridiculous thing, and it's just so hard to read and understand. And I cannot believe they think that's a good way to write it, you know? Yeah. Yeah, I think it's even worse than that. Like, you know, they'll overload like the call operator and do stuff, and it's just weird. It's a weird API. Oh, it's so bad. But yeah, I'm glad when they do super ridiculous C++, which is great. Horrendous. It grinds my gears. Something you said a while ago. See, you just get to see the code, and what's it doing? Yeah, that's it. Except for when someone writes like C89 code, where it's like one letter variable names. You declare. You don't put types in here, but then you put a bunch of types afterwards, or the beginning of the function, and retype it all out again, and then, yeah, C89 code. But it's still, I think C89 code is still better than. Well, it's pre-C89 code, isn't it? Actually, it's probably the KNRC code. Yeah, but it's still better than C++ code, modern C++. C++. Yeah, all the declarations at the top of the function, which gets a bit crazy if the function is quite big, because you just want it in the scope sometimes, and it's actually quite error prone. But yeah, functions and struts. That's all you need. It's a bit like arrays, right? All you need is arrays, maybe a hash table, and sometimes you need, very rarely, like once or twice per application, depending on how big your application is, right? You need a tree. Like, there's not many times you need, like an array is going to solve 99% or more of your problems. Programming. Let's go back to some shaders where we're traversing a tree. Ray tracer. This is where the fun begins. So, right, so I'm thinking, right, we rebuild this BVH, the top level BVH, every frame. Drawing time. And the top level BVH is going to have a bunch of instances in the world. So we might have like a bunch of tile instances, right? It's like perspective. Let's just imagine they're tiles. And this is very horrible perspective. Wait a minute, let me just imagine. Oh yeah, it's terrible. Draw the lines. One is an align tool. Oh. I want more tiles. Anyway. That's terrible. Maybe I can see it. No, I can't. Anyway. I think this will do. It's okay. We get the point. So from the view, there'll just be like a bunch of tiles. What would you give for a span type in C? That's one thing. Yeah, it's kind of okay. But yeah, they're kind of cool. I don't know. No, it could be Blender, right, innit? Yeah. Yeah, Blender's like a spaceship. I have to relearn the spaceship every time they make a new release. You know, this is terrible. But anyway, I have a bunch of instances in the world. And like, say each of these tiles will be like an instance, right? So I'll probably have like a tiled map, maybe, but I might join some of them up depending on. But that's the basic idea. Imagine each tile is an instance, and you maybe have like a little player on here or whatever. Ooh. You have a little player on here or something like that. So the way I'm thinking about doing it is because we're rebuilding this top level every frame, we're going to ray trace in view space anyway. So these objects are all going to be in view space. So you ray trace in view space. When you hit the object, you do a view to local translation. So that is stored in the instance data anyway, right? So you bring it into the local space of the object, then you do the ray tracing in the local space of the object with that bottom level BVH. And then when you get a hit, you add it to a list somewhere, and we'll deal with the translations later or something like this. Or maybe we translate into world space. And anyway, details for later. I think we can do. Yeah, so I'm thinking about, maybe if the world doesn't change every frame, but we just move the camera a bit, we could probably keep the same top level BVH and we don't have to rebuild it. But we kind of need to have a budget anyway, which supports us rebuilding the BVH every frame. But say we just move the camera, you could probably provide some kind of offset. Because at the end of the day, you're going to have to, this is your view, you're probably going to have to, I can't zoom out anymore because I'm so zoomed out, but you're probably going to have so much stuff in your BVH anyway, that's even outside of your camera, because I might want to do some kind of lighting that uses the BVH, and you need to make sure that your bounces can kind of reach stuff that's a bit further away, that's outside the camera. So yeah. So I don't know. You probably just rebuild it every frame. But yeah, so we have that view space thing. So we won't really go into world space. This view from world and things like this. Can be done. It can be done when we do shading. And I think I might defer the shading. But I might make a pixel list. Or a list of hits for a pixel, and process them later, because I think I want to try and do anti-aliasing, like proper anti-aliasing and things. But we'll see how that goes. So let's just remove these world space things. So we got ray origin in view space, ray direction. So closest hit depth, final color. We extract the base. So from the CPU side, in the push constants, we give it the BVH ref. This is the top level BVH. We get the base node index. Then we have a stack of nodes, 64 nodes. We put on the node stack ref 0. So the root children, there's up to 4 children on the root node. We'll have 0. Yeah, we'll be at the 0 position inside the BVH nodes. And then we'll just say, hey, the root node has 4 children, but it might have less, but the rest of the children are zeroed, so we'll do a reverse ellipsoid hit on them. So this will be the, then we iterate over all of the, then this is our traversal loop. So while there's stuff in the stack, we extract out the child relative index, which is 0. That's the start, then the number of children. Then we go over all the children and ray trace against those boys and girls. And if we hit, we then, if we're a parent, we just add it to the stack. It's meant to be a very quick operation, but I've got some debugging stuff here because I want to sort of like debug visualize some of this stuff at the moment. And then if we're a bottom level leaf, we're doing some shading at the moment, but I really want to take this and put it into a list because the problem is branching code is really bad because you can have some threads in the wave. You know, there's 32 threads going. Some threads are going to be on a different node, which is a parent. Other ones which are going to be on one which is a bottom level leaf. Furthermore, we're adding a new one. Oh, for crying out loud. Which is going to be on a top level leaf. So there's 3 different branches the threads could want to go down. And how does the GPU solve that? Well, it executes all of them. And it just has inactive lanes in the SIMD register, that it operates on. So this shading code, it might look kind of simple, but until you reach this function, and then it's actually quite intensive. Like it does a bunch of sampling everywhere, and I can't even find it anymore. There it is. Yeah, so there's a bunch of sampling on some stuff and goes over all the lights in the scene. We've only got 2 lights at the moment. And then it will eventually, yeah, it's forward rendering at the moment. Yeah, so if you have a bunch of threads that are inactive doing all of this, it'd be kind of crap, wouldn't it? So we probably want to just make this code just put stuff on arrays and we'll process it later, I think. So yeah, we've got this node stack. This is kind of nice. With this node stack, I think we only need 64. Because when you have a tree, I got to draw again because I think my we have a tree, right? So effectively, we're going to be traversing on a path down the tree. We start the root children. We iterate over them. If we hit it, we add the first child as a node ref to the stack. So if we've hit all of these 3, that's 3 that get put on the stack, right? That's 3 that get put on the stack, and then we pop off the stack. So I guess we'll use the one at the end, isn't it? And then we'll start looking here, and then doing the same thing again. But these ones are leaf nodes, so it doesn't matter. So the reason why I think we need 64 is because you've got 4 children. Yeah, so the most you're going to need on a stack, I think, is the max depth of a tree. The max depth of the tree is 16. So we're only going to be traveling through one. There's only one route through the tree we're going to have that gets us to this node, right? You don't have multiple routes going to the same node. There's only one parent, if you will. So because of that, is that right? Yes, there's only because of that, you only need to remember, so the depth is 16. You need to remember 4 children per layer, basically. So I think it's okay. So the first layer's got 4. This has a depth of 2 right now. So we take that same formula, depth of 2. So you have 4 nodes, potentially there, another 4 here, another 4 there, and another 4 there. So that'll give a total of 4 times 4, which is 16, plus 4, 20. There's a total of 20 nodes for the whole tree possible. But the stack, to be able to traverse it in the fashion that we're trying to traverse it in, by iterating over all the nodes and checking, these are all in the cache line, so I just want to iterate, check for hits, and if they hit, put their results on the node stack. So that would be a depth of, so it's just 2 times 4. Depth of 2, max children of 4. Is that true? So go over 4 of them, for instance, you'll put 4 on the stack, right? Then you come down here. Well, you wouldn't even need it really, because you would, the last one is the leaf nodes, isn't it? So maybe we might be able to get rid of a whole layer. Be interesting. So it could be 15 times 4. Yeah, you'd go over these and hit them or not, and then you would do some shading maybe, and then come back up and process this stack instead. Yeah, I think that's right. I heard a pointer provenance compiler people would love to have a provenance compiler people would love a span type. Huh? I'm confused very much. But yeah, span types in C would be kind of useful, but they're not really needed. The problem with span types is that size uses 8 bytes of memory, and oftentimes you only need a U32. You can just pack, like when you use a pointer in a strut, you're often wasting 4 bytes. Sorry, when you're using a span type or a slice in a strut, you're often wasting those 4 bytes. Has Helix went from 8 out of 10 yet? Yeah, it's pretty good. I'm liking it more and more. I think it's really good. There are a few little annoyances still with the build stuff. I can't run a command and get a list back and operate on that. But yeah, I'm happy with it. I think it's good. So I think we only actually need 50, wait, it's 60. That can save me some. Yeah, that can save me some VGPRs in the future. I've still got to pack this into U16s. Maybe alright. So I'm trying to say like node stack needs to be n or depth take 1 multiplied by number of children. Look at me, I do maths. Oh, for crap. Right. So you know, a true maths person would just leave it like that and leave everyone clueless. But since we're not a maths person, we're gonna fill everyone in on what's going on. Where D is the depth of the tree and C is the max number of children. In a parent node. So node stack needs to be D, right? Okay, so and then we'll answer it. So we'll go our depth, max depth is 16. Since since we're a quad tree. Well, our max depth might be able to be less. Because if we're only doing amazing. We only need to address up to 64k of nodes. Right. This could save us even more VGPRs. This would be amazing. Beautiful. So our nodes. So how much of a tree? Is it just divide by 4? Why doesn't it want to? Right, they fixed it. Okay, so I think it's just divide by 4. Is that true? Because depth of 16. Yeah, but it's times. What's the maths again? So binary tree with 32 depth can address. Yeah, because it's a binary tree, so it's one shift left, 32. That's the number of addressable. Yeah. Whereas we've got whereas because we have 4 children per node, that is obviously 16. It's 4 to the power of 16, isn't it? Which gets you the same number, 4 billion. So it'd be 4 to the power of 16. Yeah, so that's the maths, right? So this means that if we want, we need 4 to the power of something gets to 64k, and that's our max depth. 4 to the power of, is it 8? That's it, isn't it? Yeah. Right, so we only need 8, a depth of 8. That'd be great. A depth of 8. Right. Our max depth is 8. And I'm glad we're thinking this through. Because Okay. Our max number of children per node is 4, right? Our max depth is 8 because the max number of nodes is 65536. And 4 to the power of 8 gives you, 65536 addressable. Addressable nodes. Sweet. So that would then mean we only need 8 times 4, which is 32. That would be pretty sweet. So that means if we can pack them in, the node stack could be, so each BVH node ref is 16 bytes, but I don't have 16 byte size types. Sorry, 16 bits. Right, say that one again. So this BVH node ref is actually a 2 byte type, right, 16 bits. So we currently have an array of 32-bit ints because we don't have support for 16-bit types on GPU. I can add it, but I want it to support on older hardware maybe, so anyway. We are probably going to manually pack it and unpack it. So that should bring us down to 16 VGPRs then. Hopefully, if the maths is correct. We can always change that, but because I have some checking here. If we go out of bounds, if we overflow the node stack, we will know about it and it will safely error and print out to the terminal. Okay, so that's pretty good. So the node stack has been adjusted. I should really write to do here. To do pack into 16 bytes. So that should give us a speed up, hopefully, because we're using less VGPRs. But we'll see how it goes when we actually get top level stuff working. Right, so the next thing we need to figure out is how we're going to add top level support. So we're starting at the top level BVH, we're ray tracing, we hit a leaf. We need to transition to ray tracing against a bottom level BVH instead, right? So we could actually increase our node stack. Yeah, we should probably double it actually. That uses a lot more VGPRs, but well, let's just give it a go. We can always try and optimize it later. But yeah, I think we need 64. And then we'll say times 2. Right. We multiply it by 2 because we want to support a top level and bottom level. Yeah, we want to support a top level and a bottom level together or something. Maybe there's a way. maybe there's a way to ray trace it per pixel. It'd be a bit of an optimization, and it's very specialized for the view. But maybe for the view, you could say, hey, we're going to ray trace against all these through this top level BVH, and all of the bottom level BVHs that we hit on this pixel, write out to an array, and then then launch another compute shader which just looks at that array, then traverses those bottom level BVHs, and then you could probably get away with a smaller node stack and then use less VGPRs. But then if you're doing any lighting where you shoot rays from random places in the scene, you kind of need one which doesn't have those sort of optimizations. Yeah, so we've got to be careful about those specialization optimizations, but that's stuff we could think about. Right, let's stick with this. This is good. This max iterations might overflow at some point, but it's not a big deal right now. Well, no, hopefully that won't overflow. It's quite a big number. Right, so when you hit, so you always know the top level to go back to. It's the BVH ref. This will be stored in an SGPR anyway. No, hang on a minute. It will all be in the node stack anyway. Yes, it'll all be in the node stack. Wait, but they're all relative, isn't it? The base BVH node index. Ah, yes. You have to have a way to restore this somehow, you see. So you could have a boolean to say, hey, I'm in top level mode or bottom level mode. But you know, when you pop off the stack, right? So when you pop off the stack, well, you could say like bottom level stack start index. So you initialize this to something like really big, and you say, oh shoot, and you say, well, if, so you say like, so I've popped it off the stack. Maybe you call it, you start off as 0, and then you say if node stack index is less than bottom level stack start index, then we must have finished this bottom level BVH traversal. I think this will do for now. Then you'd set bottom level. The LSP is not really showing up in the shader code, which sucks. And this is where I want a really dumb implementation. Like just a string search thing to work. Because there's no help right now without the LSP. Right, node stack. Right, so then I want to restore that BVH base node. So I just copy this one in it. Let me try my key out. So I guess I could put a comment here. If we have finished, well, not even that, just takes too long. This one. We have finished traversing the bottom level BVH. Restore the top level BVH base node index, right? So we'll be able to set this base node index when we hit the instance and traverse through the instance's bottom level BVH. So let's do that now. Let's just copy that line. Whoops, I said copy, not destroy it. So here, when we hit this top level, the goal is we need to set this and do more, obviously. So we're going to get the BVH instance and retrieve that from the array. So instance instances buffer you would then say, wait, hang on a minute. Instance index BVH node, instance index node. Right, so when we hit a node, if this node is a top level leaf, we retrieve the instance index, then we get the instance from the instance's buffer. Then now we have the instance, we can get, we need to do some ray, we need to transform the ray actually. So we probably need to restore the ray back as well. That's another thing we need to do. But yeah, so we need to then so yeah, BVH base node index, and I think, oh shoot, BVH instance BVH ref. I think that's what I called it. So we get the BVH ref, we unpack it, and we get back the base BVH node index. Now we actually need to do some transforming of the arrays. So these arrays here, it says ray origin, ray direction, view space. We probably just need to have actually one called ray origin. It could be in view space or local space, we don't know. Starts off in view space. So here we're going to put in a nice comment and say these are either these are in view space for top level traversal, and in local space for bottom level traversal. So we just need to have a way to restore these again. So, just take that and yank it. Then here, when we come back out of the bottom level, we're going to go ahead and restore those. Boys and girls, right there, right. So delete, cool. So restore those two variables there, back into view space. Now when it comes to those two variables, when it comes to here, ultimately we need to transform the So we need to transform the origin of the ray and the direction such that it's now in local space of the object. So that's going to take a bit of maths by extracting the center position which is BVH instance center position snorm. So we extract that out. So half dims unorm, that's basically scale. And the final one is rotation. Which is quaternion. So we need to like, this is kind of like local to, this is local space to world. We need to kind of go, or local to view, sorry. We need to go the other way around. Somehow. Yes, you'd need to. So the direction is the easiest, right? It's just inverse rotation, inverse scale. So it's quite easy. The positional one is kind of the same. You want to translate it into the local space position, then apply the scaling and rotation. So it's not too bad. So I think it'd be something like, let's just, so we subtract from ray origin the center position snorm. So we get back is that right? Your ray is going to be in the middle of the screen. The ray origin is always going to be in the middle of view space. Move it back such that the object is in the middle of in origin now, right? And then you apply your inverse scale and then rotation. So you then, I guess in any order, it doesn't matter. Yeah, you just say, you know, div ray origin half dims unorm. And then inverse rotation. So you want to get one of those. Quite easy. That equals one of them. Rotation. Ray origin multiply vector with a quaternion. Ray, or so you can think of our position as a vector at this point in time, because like the object is in origin 0, 0 now. And wait a minute. Yeah, the object's in origin 0, 0, but our ray is a relative from the 0, 0 now. So to the so drawing term. Imagine you've got your person, box, your camera, where your ray's going through. Initially, you're gonna have a ray. Initially, you have this center position, which is a vector from this one. But then we've subtracted the center position from the ray origin now. So our ray origin was at 0, 0, but now it's the other way around. So we've got this ray origin is technically like a vector from the new origin. So it's like rotating this with the inverse rotation, and that will now be in local space. So just got to do the same thing for the ray direction, but since that is a since that is a direction only and it's not a position, it doesn't need the translation. We still do the division, ray direction, and we still do the rotation as well. So yeah, because we're doing that, we should, it's a bit of an optimization, but we should be doing inverse half dims, which will be scalar divide. So the scalar is 1 and half dims u norm. So we can then replace this with a multiply, and it should technically be quicker. Because we're doing less divisions. Because they're more expensive, right? Neat. So yeah, we're going to sort the ray origin and change to the new BVH. And we should push on the stack something. Keep doing that. Let's try that again. Yeah. We should push on the stack a BVH ref, and if you remember, the root children start at 0, and the number of children will have to be 4, because there's actually going to be probably less than 4 children sometimes at the root node. So we 0 initialize the rest of them, and we'll just do the test against them, and they'll fail. So I don't have to store the number of children somewhere else. So we put that on the stack, and then we should start traversing that bottom level BVH. So, right, how close are we to getting this to work? So I think this is the shader code done. I just got to get it compiling. But I think that makes sense, right? We point to the top. We can actually start pointing to top level or bottom levels and just traverse those. Yeah. So yep. So I think the ray tracer is now complete. I just got to get it compiling. The next thing that we need to do is actually create the BVH instances and create the actual top level BVH every frame and initialize it with the instances that we want to see on screen. Yeah. So I'm going to save that for Sunday's stream, which is at 6 p.m. GMT plus 1. So yeah, on Sunday we should have multiple instances, and we should be able to make a scene, a little tile map filled with a bunch of things, and maybe we could play about with improving the performance a bit from then, because I'm sure it's going to be terrible, because we're doing a bunch of shading at the same time as traversing, so I'm sure it's going to be really bad in some cases. So maybe we can start just seeing if there's some low-hanging fruit, if we can improve performance, before we wrap up on the BVH thing. Maybe we can have a bit of fun optimizing aspects of it. So it's not horrendous, right? But not do any sort of hyper optimizations, just all the low-hanging fruit. So we'll probably be doing that for the next few streams. But yeah, we'll probably do another devlog as well at that point. So if you're interested in watching the current ones of those, they're up on YouTube. The last devlog was, what do we do to build the BVH on the GPU? Like, what have we done so far? Thank you, Alex. Yeah, no worries. It's really cool, man. Great progress today. It's good fun. There's Discord if you come and hang out in the meantime. And if you want to get source code access, you can subscribe via Twitch or Ko-Fi and get access to code on Windows and Linux. It builds on both of them and runs on there. And you get to support me in the meantime. Yeah, let's find someone to raid. If anyone has any suggestions for people to raid, smaller channels, preferably C or C++, maybe Rust. I have a bit of a soft place in my heart for Rust as well, but nothing web at all, please. I want Eric to make more Game Boy stuff. Should I raid Eric the Wise? Oh, sorry, Edric the Wise, and get him to make more games on the Game Boy, because he started doing it and he's programming in C and everything. Oh, I need some sleep. Hey, there's me. Where's all my tags gone? Hey, I'm just programming. One of my tags too offensive or something? What's going on? I just program. It's what I do. Someone's doing OpenGL. Is he German or something? Right, I think this person will be speaking English at least. And doing OpenGL, so I think that'd be cool. Playlist? Is the playlist still going? It stopped ages ago, man. Stone Rebel, that's what we play. Stone Rebel's amazing. I think it's multiple people, right? So they make an album like every month, and it's great. Put it up on YouTube, free. Amazing people. Wait, I want to do that next. First I need to stream manager. Yeah, and then look at this. Oh, I've got my tags there. Wait. Yeah, they're there. I got tags there. Right, raid. Right. Have a good rest of your work week, guys. I'll see you all on Sunday. Thank you for coming. Appreciate it. And yeah, have a good one. Yeah, in the stream. Sorry, Catamy. Catsamoy, sorry. Bye.